Okay, next we have Michael Soule. I'm not sure that's how you say his last name, but I just know him as My Snozberries, which is the best Twitter handle. And I met Michael at DEF CON Black Hat last year. After one of the sessions, we got to talk about some of the identity stuff, and he's going to talk about some of the topics here that the keynote talked about, Matt, as well as Steve, about how critical it is to use a centralized identity to manage resources. So Michael's going to talk about how you can do this to manage your cloud infrastructure. So Michael, are you on?
Yeah, I'm out here.
Oh, there you are. Awesome. Good to see you again.
Good to see you. Awesome to be here too.
Take it away.
All right. Yeah, as Mark mentioned, this is a topic that's been on everybody's mind this afternoon. So this morning and afternoon, it's a fantastic topic. It's completely one of the more difficult areas for sure. I've seen it scan go from extremely small environments that have absolutely no handle to huge 100,000 user plus size environments that understand this very well, and everywhere in between, and vice versa as well. So if we think about this going back, way back, and if you have a social security number, you're aware of that, or if you have another national ID number, similar concept. But this is something that is a hard problem and something that no one has yet to really have a total comprehensive answer around, just because it's really hard to define who an individual is digitally. When we think about that, there's different sources of truth, there's different systems of record, and it's part of the reason why you think about identity theft. And that's only a couple $billion industry. But when we think about the identity theft industry in the protection sense, that's another like 14 billion. And that's not even getting into the digital security from like Jess's role being an incident response and actually proactive security as well, which are even larger industries. So this is a really big issue, and it has a long history, including going back to the original implementations from the ITUT about what Active Directory is even based on. And what we think about this is, this was one of the first attempts to really define those digital identities, define who I am, define who you are in a digital sense, and make sure that there's a common understanding of individuals within a system. And this transpires today in what most organizations have as a Microsoft Active Directory forest. And it's great technology, and it's proven its purpose, and it's definitely still one of the top out there, and we can build on it. And that's what the cloud's offered us, is a way to extend that existing investment and make sure that we can leverage those tools in more comprehensive manners. It's also one of the problems too, because we know there's sometimes multiple systems of records, like human resource information systems. We've seen systems like ERPs be the system of record, so enterprise resource planning be the system of record, and it's a complex discussion, definitely. So X500 was sort of the start, and then Kerberos builds on that, and Kerberos really helped with that centralized authentication and authorization model. And so now we're getting into the actual protocols that allow me as an individual to authenticate and prove my authentication to you as a service provider. And that's the foundation of when we're taking this into the public cloud, is I need the identity provider to be able to validate who I am to different service providers. Kerberos was one of really the first implementations to that, but it was tricky for the business-to-business trusts. If you've ever done inter-forest trusts, if you've ever tried to go through a merger, acquisition, divestiture, those are painful events, and they definitely aren't something that most people look forward to. Because it's very hard to segment those environments once they're really tightly coupled. And where does that get us today? Today, that gets us into an environment of modern authentication. And when we say that, we're talking about web-based authentication protocols that are using HTTP as their transport and using SAML or OIDC as the authentication method, and then potentially having extensibility on top using OAuth for authorization and advanced claims rules justifications. And so OAuth and OIDC are still on sort of that cutting edge side. They're still only about a decade or so old. And SAML is really where we're seeing a lot of the enterprise use come from. And that SAML as an authentication protocol essentially lets us integrate that federation between different service providers with a single source of truth. And so that solves all of our history and gives us that one repository that we can build off of and make sure that our authorization structure extends into our public cloud providers rather than having to recreate all of it. So as part of this, we're going to do a demo in AWS of what some of this looks like. And so we're going to touch on a few foundational components of AWS here. Within AWS, you have what are accounts, and each account is a segmented tenant. So anything I do in one account is completely independent of another account I may own. Most customers or most companies will have multiple AWS tenants. It's a best practice. AWS recommends it. It provides you lateral segmentation. So from a security perspective, there's huge benefits. There's also business benefits from being able to have consolidated segmented billing and making sure that each of those are going to a dedicated cost center based on the account using it. And within AWS accounts, we can create IAM policies. And those are our authorization rules. Those tell us who can take what actions. And those are something that we integrate with different services. And those AWS services, for example, Lambda, would allow me as an administrator to trigger a Lambda function so that it executes, or create a new Lambda function, or possibly delete an existing Lambda function. Policies are assigned to users, but they can also be assigned to an IAM role. And roles are a unique aspect to AWS. They let us assume a role and act as a role because it has policies applied to it, but we don't actually need credentials to log in. So it's sort of a known trust principle that we're able to have a delegation into, if you would. And another note, you can actually have things like Lambda functions or EC2 instances, Elastic Compute Cloud, virtual machines, actually assume an IAM role and be able to take any of the actions applied to the policy as if they were an administrator. Good thing to note too is policies do have the many-to-many relationship, so there's no real limitations from an authorization standpoint, but it does make for a complexity consideration there. And then we get into our service providers. And within SAML, you've got your service providers as your SPs and your identity providers as your IDPs. And those are the core tenets of the rules in an authentication trust. And that federation, that trust, is the identity provider proving that the user credentials are valid, sending claims to the service provider that tell the service provider that that authentication is valid and any conditions about it. But a good thing to keep in mind, again, AWS accounts are segmented tenants. So that means everything I do in one account, I have to do again in a different account. And this causes difficulties when we're at scale and when a best practice is to actually have multiple accounts, because then my actual authorization policies may be very consistent and I may only have 3 or 4 roles that I actually need across my organization in general with some ancillary secondary roles, but maintaining that consistency and that global single view is very difficult. So these are the main components we'll be touching on, and we'll definitely make sure to cover them all a little bit more detail. But as we think about like a use case with Contoso, we'll use, we have multiple AWS accounts at Contoso.org. And in Contoso.org, we could create user accounts or user credentials in each account. We never want to do this. Anytime you need to give a user more than one set of credentials, you just created so many problems for yourself, your security team, everyone involved, including the user. And so this is at the bare minimum what we need to avoid. So an easy answer is we can create a single user in an identity tenant, sort of a bastion AWS account, and that can be segmented from your other accounts. That user can then assume roles into those individual service accounts. But even better, one of the things we can do is, rather than having to recreate our users within AWS in our identity AWS account, and then that user with those unique credentials would have to assume roles, we can change that user and identity into the SAML service provider functionality. And so when a user from our Contoso on-prem Active Directory utilizes Active Directory Federation services, utilizes Azure AD Enterprise apps or another identity provider, they can authenticate into that AWS identity account as an assumed role and then switch into the service accounts as necessary or as we authorize them to using different policies. So this provides us a really good platform to make sure that our users have a good user experience. We make sure that we maintain that single end user identity so that when we are trying to go through an incident response or we are trying to track who has access to what, we don't have to first correlate 5 or 10 different credentials into a single individual. And so as a starting point, this is where we want to be, but we still have an issue with consistency across all of our service accounts, because these could be a single application, SaaS application that we provide to our customers. This could be a business-to-business ETL job, extract, transform, load job. This could be a different application managed by an entirely different team. This could be a shared services account. We could have tens to hundreds of AWS accounts for different use cases. And even to the extent where individuals will have their own dedicated AWS accounts. If you've got a team of 10 developers, why not give each of them a dedicated account where they can go test and actually build and obviously put controls and make sure that they're limited in what they can do so they don't go spin up a giant machine learning algorithm in Bahrain or somewhere. But we want to control and still give them the ability to practice and learn these new tools. So circling back to this consistency in the management of the roles and policies, these are the things that we have to create in all those accounts. We have to make sure that we have some control over. We could use a third-party identity management system. We could use things like CloudFormation and other infrastructure as code platforms that have these dedicated functionalities in them too. But we're going to propose a different option here in a second. Another note here too is we even see this and strongly actually recommend this even when you're considering things like Azure AD Tenants. So Azure AD Tenants, as you're familiar with, are also the foundation for identity of O365, Office 365. Something we strongly recommend for a lot of our customers is to actually have two tenants. One tenant would be your user tenant, where your O365 subscriptions exist, and those services that are end user facing exist, if they do exist as Azure resources, and a second tenant that's your actual infrastructure. And those are completely independent, and then you utilize business-to-business trusts to be able to access those and elevate into the privileged accounts where your infrastructure exists. And that way you get almost that similar concept of a red forest or an enhanced security administrative environment. So you're able to make sure that that segmentation and that lateral potential overflow is completely segmented, and you're making sure that on-prem, we wouldn't really give our users access to VMware directly or vCenter directly. So why would we do that in Azure? Why would we give them portal access? Why would we ever want them accessing Azure resources directly unless they are in a form of a developer or another user of those resources, in which case we want to take additional administrative controls for their functions. So as a note, this does expand beyond just AWS. So how can we solve this as one idea? So one idea is we need a central location. And in this case, we're just using simple storage service S3 in AWS. We've talked about it with blocking public bucket policies, making sure that different controls are in place in your S3 buckets, and they are a fantastic tool. It's cheap storage. It's a quick way to get a central unstructured data location. So it fits for our use case. Could you replace this with a database? Could you replace this with a configuration repo? Yes, there's countless options to improve this idea. There's many different ways to accomplish the same workflow. The goal is just to make sure that you have some control in place to answer these issues. And so what we do is we take our IAM roles and our IAM policies, which are JSON files. We'd save those into an unstructured location, our central storage location, which is an S3 bucket. And in all of our service accounts, we'd be able to have a compute function. So in this case, we'll use Lambda to actually go to that bucket and say, hey, what is the state I should be? And we can trigger that Lambda function using what's a CloudWatch event to effectively be like a cron schedule. So we could have it every 15 minutes, every day. CloudWatch event's going to trigger that Lambda function, and that Lambda function can go to that central location and say, hey, are there any new policies or roles I need to implement in IAM today? Again, there's many ways to handle this, and we'll touch on those in the additional resources section. But this is something that also gets us access to some new tools. So why Lambda? Why would we use Lambda for this use case? Well, it's free, more or less. You get 1 million requests per month per account. This could just as easily be Azure Functions or on GCP. The platform doesn't matter. It's more the concept of trying to use these new technologies. And so another concept is you're gaining some practice with scripting in a way that's very methodical, in the sense that you're creating very tangible outcomes of your scripts. You're focused on a single script doing a single task, which, if you're anything like me, have the bad habit of just making 1,000 lines of code that does everything. And so by building this into a more scheduled model and an actual functional workflow, you're sort of coaching yourself to be a better implementer. You get direct integration with other services. So this is a huge one. As we mentioned previously, a Lambda function can assume an IAM role. So that means that I don't have to build in any credential mechanisms. I don't have to worry about shared secrets so that my Lambda function can perform roles or perform functions. It can assume a role and then execute those without even needing any shared secrets or API keys. This is fantastic when you compare it to maybe I'm running these scripts traditionally on like a shared services, a utility server as scheduled tasks. Now I don't even have to manage API keys. That's huge. I mentioned it just now, but you get rid of that purpose-built utility server. So again, another opportunity to just use the cloud for what it's meant for and try to migrate single use cases into very small, actionable, tangible outcomes. And then lastly, you get experience with current trends. Serverless, functions as a service, all the different buzzwords, Lambda functions, they have been a hot topic. And it's something that your developers, if you have on-staff developers, may be looking to leverage, or it's something that an adversary could leverage against you. So having familiarity with these tools, these technologies, it's just beneficial to be familiar with. And this is a good use case to learn these technologies and something that you can gain double benefit from. And so right now I will hop into the demo. So to start off, this is the Lambda function we'll be using, and it's a PowerShell script. So this uses PowerShell.NET Core. Again, we get to use some of that fancy new technology. And we're actually using the AWS modules to be able to perform different AWS actions, all from PowerShell. And so this is very simple. It's not built for a production use case. It's sort of a framework to get a general sense of what some options are. But we'll show what this actually does here in a second. So to start off, I'll bring over my app launcher. This is an example of what a user's use case could look like. So in this case, I'm using Azure AD as my identity provider, and they've got this app launcher dashboard, My Apps. Something worth noting here, my enterprise apps are actually, they just were made unlimited for free. So there's a lot of value in what Azure AD is bringing to this topic domain. I won't tangent off too far, but Microsoft's been doing a lot in this realm to really benefit customers and even free customers. So lots of options. We've got a guide that I'll show after this that touches on this as well, and their documentation's also pretty darn good. So what we'll do, we'll hop into AWS, and if one of the nice things, just to show it quick, that application is actually assigned by an Azure AD group. So now the same groups that are synchronized between my premises Active Directory domain and my Azure AD domain, now I can use those same groups to inherit group access into my enterprise apps. And now I don't have to even rebuild the authorization model I've already built out in Active Directory. So there's a lot of value in understanding how to get this inheritance model to sort of chain across as well. And there's a lot to dive in there, so I won't go too deep, too far off track, but just keeping in mind plenty of possibilities. So like I said, we needed a central location to access these files from. What I will do is hop into our bucket. And one quick thing I want to make note, because this is a big discussion topic. This was talked about earlier. Block public access to your buckets unless it's an explicitly known use case. It's they're trying to help you when they're doing this, and when you're using things like bucket policies, you can get extremely granular and use Iam policies or bucket policies to control that, and you don't need to use the internet. So, or just open to public access over the internet. So please keep that in mind. We've touched on that a couple times. So what I just did is I went in, so what this framework is basically, this is the account that we want to be a trusted entity that I can assume a role from. This is the name of a role that I want to be created in all my service accounts. And then this is the actual JSON of what I want for policies attached to that role. And in this case, this JSON file is, all it is doing is pointing us at the AWS resource name of a managed policy, which is the administrator access policy. This is one of those moments where I say, do as I say, not as I do. Role-based access control, try to use more granular authorization. This is a demo, so please take this with a grain of salt. Keep in mind, limiting access is still best practice always. So what we'll do now is we'll hop into one of these service accounts. And so I'm switching role into a different AWS account here. And I still have access to that bucket because of the way that the bucket policy is configured. And if I go into Lambda, I'll show you what the function looks like quick. In this instance, this function is not configured with the CloudWatch event trigger, just so that I can show you through a manual trigger that there's nothing else funny happening in the background. But it's .NET Core, it's already been uploaded, and it's effectively ready to go. So what will this do when we execute it? It will actually go into the IAM functions, and there is a test role in here that we saw defined in the bucket that should have the administrator access policy. So as you can see, this is already existing. So let's go in here and delete it. So policy doesn't exist now. And if we just hop over to a console quick, I'll invoke that function. And again, invoking from PowerShell. I'm a fan of PowerShell. It's a great tool, really helpful. If we refresh now, we've got our role. It's got the trusted entity as the account. And if we go in, oh, policy's not attached, but same general idea applies. So small gaffe there. Let's see, I just refreshed it. We'll see if it applies this time. But idea is the Lambda function would attach the role. Miss on this demo, but that's the general idea. And so that gives you an idea of what role assumption looks like within AWS and within IAM specifically, as well as utilizing SAML to start that entire journey. So let's hop back over to the presentation here. Okay, thank you. So a couple notes. Code is available. This is something, again, I don't intend this to be used as a production use case. This is something that's sort of just an example of what's possible. It could be a good starting template, but there's definitely a lot of condition handling you'd want to use. There's also a blog post that talks through all of the different components for getting this deployed. There's step-by-step instructions to see exactly how to actually deploy all of these components using PowerShell against AWS. So you actually do all of the deployment from the console as well. So another great way to sort of practice different skills. As I mentioned, this isn't necessarily the best way to accomplish the same goal. There's a tool by Olaf who created organization formation. So this is a centralized repository to be able to push out those configurations from a single location and do it actually across different AWS accounts and different AWS organizations. And it's sort of like a master above even the organization tier. Also, a month after I did all the work to build the blog post and get that posted in February of this year, AWS added CloudFormation stack set support at the organization tier. So that means that you can use AWS's native IAC, infrastructure as code tooling, to achieve similar functionality in your IAM configurations and push that from an AWS organization. So prior to that, you either had to use organization formation or you had to use something like Terraform or a third-party infrastructure as code platform. As I mentioned and showed, I used Azure AD as my identity provider. Really good platform, good examples in the documentation. This is the guide that shows setting up the role assumption. So being able to use different roles and different accounts through single applications or multiple applications published in Azure AD. Another note here is AWS does support passing tags into a SAML role assumption. So when I assume a role from my SAML service provider, my SAML identity provider can attach additional claims to that assertion that have tags that need to be applied to any actions I take. And so if you're building out an attribute-based access control methodology, and you're trying to get some of those defensive controls in place based on different tagging criteria, you can pass tags directly in from your identity provider. So other ideas too, you could use this type of functionality for bootstrapping EC2 instances. We've used it for, you can, basically the sky's the limit. The general idea is the public cloud offers a lot of new tools and a lot of new functionality that in the past was either a hard, difficult problem or something that was a little bit obtuse and maybe not worth the effort. Now, with the way that some of these functions are integrated, it can be a big time saver. Last, reach out to me. I'm passionate about this stuff. I'll do my best to give you as much time as I can. I try to find really fun, interesting, difficult problems to solve. So I always enjoy having a little puzzle to work on and think on. But if we're thinking about takeaways from this talk, what I would ask is, step one, get an identity provider deployed. So make sure that you have some functionality, whether it be Azure AD, whether it be ADFS, whether it be Okta, One Login. There's so many. Make sure that you standardize on one and you have a single source of authority for all of your credential data. That's the critical piece. And try to standardize on your authentication protocols. I will say that it's an ever-changing battlefield. We mentioned at the beginning, OIDC is pretty new, cutting-edge stuff. So as soon as you probably get all of your service providers supporting SAML, you're going to get the next one who says, I only support OIDC. So it's going to keep evolving. It's no longer just Kerberos and NTLM. It's SAML. It's OIDC tomorrow. So get an identity provider, get familiar with this, understand how you're going to do these business-to-business federations. In AWS side, and even the Azure side, define a multi-account strategy. Define where you want your different boundaries to be. In the cloud, one of the things we see way too often is it's still taken for granted that the network is your segmentation point. It's no longer that case. You have so many different ways to segment for lateral movement control to be able to make sure that there's very isolated environments. It really provides so many different options. And that's something that's worth reflecting on and just asking yourself, is there a way or a new tool that I could use to segment this differently than, oh, I'm just putting all of that in this VLAN and putting ACLs on it? Because we can do it where it's pretty much completely independent. And that's something we actually even see with like franchisors, where they still need to share services down into franchisees, where they'll have each franchisee has an Azure AD tenant, but the franchisor shares services through things like private link and different services to be able to maintain control and become almost like a service provider down into their entities. So a lot of new opportunities, but the core focus, determine what an account means to your organization and how you can use that as a security tool. Then last piece, these do scale easily. There's no cost component around creating user objects, at least in AWS and Azure AD at the base tiers. And So definitely as you get into advanced functionality, this changes, but policies, roles, user accounts in general, they don't cost you whether you have 10 or 100 or 1,000. So make sure that the most critical piece is an individual as a person gets one set of credentials, and you make that experience around their login experience as seamless as possible. So those are the three major takeaways: getting that identity provider foundation set, getting that multi-account strategy set, and then making sure that wherever possible, your authorization policies are as limited and restrictive as possible. And I believe that is it. So Brian, Mark, did we have a couple questions there?
Yeah, there's Ken. So we had a couple questions that were provided via Zoom. The first one is from Charisma Island. He said, will a single identity access tenant with access to all compartmentalized tenants create a single point of attack for attackers? Excuse me.
Yeah, it's a great question. And it's interesting because by technically just migrating into the cloud, you did make yourself a single platform to attack. Password spraying, as mentioned in a previous talk, was a really big topic because Exchange Online, everybody was centralizing their mailboxes there, and with legacy authentication, it was easy to target. So you're exactly right. There are concerns that you are basically saying, here is the target. Security through obscurity is a non-thing. So is that a concern? Is that something you need to make sure is in your threat models? Yes. Is that something that the technologies provide ways to mitigate? Yes. And so if you're making sure that you're rotating your SAML signing keys and your certificates, your private keys are maintained in secret, you're usually not going to have concerns there. You're muted, Ken.
But wouldn't you also say that's also an argument for having multiple tenant accounts, so that way you can compartmentalize it? For example, if you have developers in production, your developers don't need access to your production account. Your production operators account don't need access to your developer account.
Yeah, and that's a good point too, is segmenting that way too helps you scale it out in a way that does prevent, oh, I got domain admin and game over. You can even get it to the point, we've seen many customers get to the point where their production environments don't actually even have user access at all, except in a break glass scenario. So that basically the only thing that can actually take actions in that environment are code deployment pipelines or break glass situations.
Yeah, that's definitely the way to go. So his follow-up question is, to clarify, he's trying to understand how you would control the blast radius for the other tenants.
Yep.
And I think we may have already answered that by basically allowing them only access. Yep. So one of the examples that I use is, let's say you have 5,000 employees and 10 accounts, which is actually a low number. Now all of a sudden you have 50,000 different identities to manage. So that's a lot of different identities to attack, to manage, and so forth.
Definitely.
Well, I have a question for you. Have you dealt with using command line interfaces with a single sign-on provider?
Yes, it's a headache. Usually, depending on the situation, using a service like Azure Bastion or using an EC2 jump box or using even the specific AWS service, AWS Run and Service Manager. So SSM Run, utilizing a service so you don't actually have to log in as a console, except in a development tenant, is usually the way around that. But definitely we've seen customers build custom programs just to manage SAML tokens for command line access, just because it is one of those headaches and growing pains for sure.
Mm-hmm. And I want to apologize to Charisma. I got your gender pronoun wrong, and I'm so sorry for that. It's sometimes hard to tell online and I made an inaccurate assumption.